Welcome back. We have Dr. Paul Laviolette here to my left. I would describe Paul as definitely a man ahead of the times, a very intuitive scientist who has a Ph.D. in systems science, has authored 6 books, president of the Starburst Foundation, which was founded in 1984, where he's conducted interdisciplinary research in physics, astronomy, geology, climatology, prebiotic evolution, SETI, and psychology. What do you think of that? Wow. Wow. The term multidisciplinary certainly comes into mind. A very imbalanced person. He's the first to do quite a few things that are definitely noteworthy. First to cast doubt on the Big Bang Theory, credited with the discovery of planetary-stellar mass-luminosity relation, which demonstrates that Jovian planets, brown dwarfs, and red dwarf stars all conform to a common mass luminosity. Predicted that high-intensity volleys of cosmic ray particles travel directly to our planet from distant sources in our galaxy, a phenomenon now confirmed by scientific data. Discovered high concentrations of cosmic dust in gold and ice polar ice, gold and ice age polar ice, indicating the occurrence of a global cosmic catastrophe in ancient times. I'm juggling here between reading this and holding these two things, so bear with me. He's the developer of Subquantum Kinetics, a novel approach to microphysics that not only accounts for electric, magnetic, gravitational, and nuclear forces in a unified manner, but also resolves many long-standing problems in physics, such as the field singularity problem, the wave-particle dualism, and the field source problem. It is my absolute pleasure to introduce Dr. Paul Laviolette to you today.
Thank you, Susan. This is my website. I have 2, actually, Sphinx Stargate, etheric.com, and the Starburst Foundation has one, starburstfound.org. You're welcome to visit. I don't know how many people have heard of William Tompkins here. Without this fellow, we wouldn't have gotten to the moon. NASA was doing Stone Age rocket science until this guy told them, you should use a clean room to assemble this and a lot of other things. So he's quite a credible source. He's worked in highly classified work for all his life. And he, in an interview in 2017, he said, in 1942, Secretary of the Navy Admiral Forrestal was told that every book in the libraries, in the colleges and universities, every book on this planet is misinformation. All over this planet, books are not telling the truth, whether it's medical, solar system astronomy, science. Every person, every Ph.D. on the planet has been given misinformation. Hey, it may be a little exaggerating, but that's the idea. Huh? Okay. So here's some trash that I believe needs to be thrown out, to be emptied in modern physics. Classical physics is pretty good, but when you get to modern physics, to make this transition in paradigm, where the goal is to get out of the closed system view that we're fed today from the physics community to an open system view, where free energy is possible. So start with the Big Bang Theory, expanding universe, space-time, special relativity, general relativity, black holes, wormholes. Probably I touch on some people's favorite subjects here, sorry, but this is what I believe needs to be thrown out, and I have evidence to back up the reasons. String theory, quarks. A lot of physicists say we should throw out string theory. It takes up too much mathematical time of physicists and mathematicians. Quarks, gluons, quantum mechanics, quantum electrodynamics, wave-particle dualism, the collapse of the wave function, the Copenhagen interpretation, dark matter, dark energy, the second law of thermodynamics, energy conservation law, of course, and Newton's third law. So our goal, I believe, is to modify the first law of thermodynamics, that energy is strictly conserved. So question is how to bring down conventional physics, defeat the first law of thermodynamics in its current form, and establish the free energy paradigm once and for all in one easy step. So imagine that I'm your drill sergeant, and this is the enemy here. Represented by, sorry, Leonardo da Vinci, but I'm using his diagram. Imagine this is corpo physical conventionalis, meaning current body of knowledge of the physics community. Now, to bring down physics or induce a paradigm change towards open system universe, you want to strike at the weakest point. So where do we have the weakest point? Right there. And what do we choose out of this list? There it is. The Big Bang Theory is the weakest point at this moment. Because actually a lot of cosmologists are fed up with it. It's causing them so many problems. In fact, you see long lists where physicists and astrophysicists sign their names to get rid of the Big Bang Theory. It's been disproven many, many times, and yet they keep teaching it in the textbooks, and they'll even reject your paper if you're saying anything against it. But it's sort of like hanging from a string. So this is the first thing that I believe is ready to fall in this body of knowledge. Here's one example. Cosmology tests what we use to test theories in cosmology, where we compare the theory against the data. And this is the galaxy angular size redshift test, where on the one axis you plot the galaxy redshift. Now, conventionally, this has been interpreted as due to the expansion of the universe that light is redshifted. So as you go further away, you find greater redshifts of galaxies. And the other axis plots the angular size of the galaxy. So as you go further away, the angular size of the galaxy should decrease. And I don't need to use the pointer at this point. I can use the laser pointer on the other place over here. But it pretty much shows you the comparison of the expanding universe Big Bang Theory, which is the upper dashed line, is way off from the data trend, whereas what's called the stationary universe tired light model, which is the alternative to the Big Bang, is right on. I mean, you couldn't ask for a better fit. So tired light model was actually proposed about the same time as the Big Bang Theory, or the expanding universe theory. At the time Hubble was putting out his data and publishing his data, Zwicky published about one interpretation is that the redshift could be interpreted as a loss of energy in the photons coming from the galaxy. So what we see here, and actually the data supports that energy has to actually leave the physical universe. So it's a non-conservation of energy involved. Because if it's conserved energy, it means the photons have to be hitting something and energy is converted into some other form. But if that's the case, you'd see blurry images. And the other problem with that is that we see the redshift both at visible light wavelengths and at radio wavelengths. And it's the same. So it's very difficult to have an explanation at both those extremes coming out the same numbers. So the data here refutes expanding universe theory and therefore the notion of a Big Bang. It suggests that energy is not conserved in intergalactic space, so it challenges the first law. It shows that the first law, thermodynamics, must not hold universally. And we're talking about billions of light years of space here, as far as the redshift goes. Now, this is the opposite of free energy. This is energy lost from the universe. But we'll see. There's the brighter side of the coin. So you see the evidence around in different articles. Here's one from Discover magazine. Could the Big Bang be wrong? These have been coming out over the last years. Big Bang theory had gone through a crisis with the Hubble telescope shots back in the 90s, and they were showing things that didn't fit with what they expected. And then that all sort of got swept or forgotten or swept under the rug, and then they kept saying the same baloney. Here's another problems with the Big Bang theory. Here's one from Scientific American. Cosmology has some big problems. Oh, excuse me, here. Cosmology has some big problems. New Scientist. Did the Big Bang really happen? This is 2005. So this is a current situation with the Big Bang theory. The question is, when will it fall? And what will replace this closed system view, which is really viewing the universe as if we're living inside an Aristotelian sphere. In Aristotle's time, it was just outside the solar system, the boundary. Now we put it 13.5 billion light years away. So what will replace the Big Bang theory, showing that it's in such bad shape? And I should mention that the test I've shown is just one of many tests. There's other cosmology tests. There's something like 5 other ones I could put up here, but I don't have the time. And by the way, I published 4 cosmology tests. On all 4, the Big Bang theory was way off, and the tired light theory was the closest to it. And that was in 1986. It took me 8 years to get it published, rejected by 13 journals, but finally Astrophysical Journal accepted it, which is one of the leading journals, astrophysics. And the beauty of that theory was it was like a Chinese handcuff for the Big Bang. You put it in and it can't get out, because their trick in the past, the Big Bang theorists, they just plot their theory, don't plot any other theory. And to get it to fit the data, they make cosmological adjustments. And they always do it with one test, because what I show with the 4 tests, if they do their little tricks and they move their theory model closer to the data on one test, it goes further away on the other test. So the best way is to compare the cosmologies equally, and you say we do no assumptions, just whatever the model predicts, and you find out always tired light model comes closer. So when this falls, currently we have really a yang view of the universe, a Big Bang, to no pun intended. So what will it be replaced with? And now the yin view of the universe, parthenogenesis, virgin birth from the 0 point, continuous matter creation. And Virgo is a good constellation to represent this. If you get into astrology and you see that Virgo is really showing the main creation center in our region of the universe, the Virgo cluster, and we're part of the Virgo supercluster. So here's an example of enormous amount of creation in our neighborhood. And the ancients knew this. Whoever put that constellation there knew that. In fact, she's pointing at the center of the cluster. And with her other hand, she indicates the equator of the galactic supercluster, which is incredible. How did they know that these were galaxies and not just stars? Why was this special for them? You know, raises a lot of questions. I deal with this in Genesis of the Cosmos book. The thing is, if it didn't happen all at once, it means that this is happening gradually, continuous matter creation. This is, again, a violation of the first law of thermodynamics, because we're creating matter energy, in effect. And this is a scheme that is predicted by my theory I've developed, which I'll talk about in a moment, called subquantum kinetics. And you begin with, let's see, okay, here we go, the laser, okay. Neutrons materialize in space through zero-point energy fluctuations, but they have to be a very big fluctuation to get it above the quantum level to nucleate this. That decays through beta decay to a proton electron. Now, once you've formed a hydrogen atom, because these will, of course, attract through electrostatic attraction, now the probability of forming another particle goes immensely, skyrockets way up, because in this physics, gravity creates a fertile region. And in the vicinity of the proton nucleus of the hydrogen atom, you have a little gravity well. So now you've increased enormously the probability of a fluctuation nucleating another particle. So it's just like genetic reproduction, cell division, you know, one creates two, two creates four, and so on. And so you'll populate a whole cloud of galaxies, a whole cloud of hydrogen out there. In fact, we see blobs of hydrogen gas out there, and they're energized by some energy. They can't figure out what it's come from. Well, it's coming from beta decay, and that's quite a lot of energy that illuminates these clouds out there. This eventually will condense into a primordial planet, which, remember, it's below 3 degrees Kelvin out there. So hydrogen is very sticky. You know, it's a liquid or it's ice, you know, and it will stick together. You don't need gravity for that to happen. So we're dealing with, you know, billions of years for just these first stages, and that will grow, because remember, matter produces more matter. So your planet is going to eventually grow into a primordial star, red dwarf, and a regular sun-like star, and it will have a solar wind, so it's going to have planets forming around it, gaseous planets. These will start growing or continue to grow, and you'll develop this into a binary star system. Eventually, you get a whole cluster of stars formed, star cluster, which will eventually evolve into ellipsoidal galaxy, dwarf ellipsoidal. The core star at the center, which will be the oldest star, the first primordial star, will be extremely massive. It could be hundreds, thousands of solar masses in the early stages, and it will start having outbursts, explosive outbursts, which will blow this dust and stars outward along an equator to form a spiral galaxy. By now, it's probably grown to hundreds of thousands of solar masses. In the case of our galaxy, 4.3 million solar masses. This keeps going. It's ejecting daughter galaxies from the core. Things get split off. You know about ARP's work, Halton ARP. He's shown this, that the cores can actually divide and spit off pieces of each other. We see the evidence in our own galaxy of orbital galaxies, small dwarf galaxies or star clusters orbiting our galaxy along a certain plane. Eventually, this whole area fills with galaxies, with stars, and eventually evolves into a giant elliptical galaxy, because this becomes populated here. But if you look at giant elliptical galaxies, you'll see the original spiral galaxy equator here. This whole thing is presented in a video I produced called Parthenogenesis, Sacred Journey. we'll have a clip from it later. It's based on subquantum kinetics. This is my book. Subquantum Kinetics, I first published it in '85 in the International Journal of General Systems. Physics journals wouldn't touch it because it was talking about ether. Actually, when I first set out to create subquantum kinetics, I wasn't planning to create an ether theory. I was inspired by Einstein's idea of bunched fields, and I was thinking that the the idea of the reaction-diffusion model could be a good way to create bunched fields, like solitons. Something that nobody had tried before. And as I was proceeding to develop this, I realized, well, these reactions involved in the reaction-diffusion processes at the subquantum level, they were subquantum. They weren't dealing with fields. I started thinking in terms of fields, but said, no, fields are formed from these, whatever is reacting. So I said, I must be dealing here with an ether, with etheric reactions. And so it's basically an ether theory. And it was published in this, the '85 issue published 3 papers, and I collected them together to form the book, which came out in '94, and has gone through 4 editions now. It kept growing and growing and growing, and now the 2012 is an e-book. Whoever buys the 3rd edition out there will get the e-book free if they leave their email address or have a computer here and get it directly from me. And Gene Manning and Susan Manowicz's book, they have a section in there about subquantum kinetics, how I came to the theory, which is very well-written books, and I really highly recommend it. And they really did a good job explaining the personal side of how it developed for me. So this is the current approach taken by physicists. The blind men are the physicists, and the elephant is nature, and they're blind because they don't know what they're observing. They do a certain experiments, like they touch a certain part of the elephant, and they draw conclusions, they form a model about what they find, but each one does a different experiment, so you come up with all these different models. And then they have to sew them together, and that's what's called the unified field theory that we have. It's really a patchwork quilt, because what it means is they ignore all the inconsistencies between the various approaches. For example, general relativity, Einstein tried all his life to unify it with electrodynamics and wasn't able to. Now, the approach of subquantum kinetics is you don't start with the elephant, you start with its genetic code, and you grow the elephant. And you compare the elephant you grow from the genetic code you start with and see, does it match observation? So here we're taking a modeling approach. So experimentation comes as secondary. Modeling comes as primary, and actually theory, because you have to come up with the right equations. And I started in my discovery of systems theory. I was developing my own system theory at the time. I was in the University of Chicago in business school. And it just happened, our course I was taking, organizational administration, talked about general system theory because it completely revolutionized how we look at business organizations, more like living organisms. And it was developed, system theory was developed by Ludwig von Bertalanffy in the 30s. And I was very relieved because I thought, here, I had to develop this. Nobody else had seen it. And here, von Bertalanffy had developed it, and there was, in fact, a Society of General Systems Research. And the problem was it wasn't generally taught in school, so you sort of had to discover it. And that's the way all the system theorists, they set out. They realize everything's so fragmented, we need to have some unifying paradigm. And they end up developing their own theories along that line. Then they discover that other people have walked the same path. You know, we come together kind of. And the subquantum general system theory has gone into biology, engineering, the physical sciences, psychology, sociology, education, everywhere. So it's very mainstream. And subquantum kinetics is basically an application of these systems concepts to physics. So I was the first to bring it down to the microphysical level, is to apply it. And at the time I was doing this, these new things were just coming out about chemical waves. They were just being discovered and published in like Science magazine. On the front cover, you saw something looking like this. The Belousov-Zhabotinsky reaction. It's an open, what's called open reaction-diffusion system, so it's in a way lifelike. It's an open system like we are open systems. And they were interested because here's an example of how a second law seems to be violated. At least, well, Prigogine developed what he called non-equilibrium thermodynamics, which is a new branch of thermodynamics to allow this to be possible. It's the thermodynamics of open systems. And here you see ordered patterns create spontaneously. On the left, you have the initial state of the reaction where everything is smooth, and now suddenly you create these patterns if you wait long enough. And they're actually little propagating chemical waves that come out. And I thought this, something like this would make a beautiful model for a subatomic particle. If you could get it to have a nucleation center, like a soliton effect. And also Prigogine's work was coming out at the same time on the brusillator, which is the simplest reaction-diffusion system that they had developed. It was a theoretical system which they used computer modeling to show the properties. And in that case, you would develop a wave pattern as a final state, but the problem is it wasn't localized. And my goal was to try to tweak the brusillator reactions to make a model that would be localized. So subquantum kinetics has many advantages. So far it has had 14 a priori confirmations. Most of these are cases where I made prediction and later things came out to verify exactly what I was saying and was totally different from what standard physics was saying. So it has a really good track record. It beats general relativity, for example, by far. It operates on the same principles and concepts as those used in biology and chemistry. So now we're getting away from the mechanical approach to viewing the universe around us to more to the chemical or life sciences. It's holistic, it's unified. It avoids the paradoxical results and pitfalls of standard physics. It makes few assumptions and is mathematically far simpler than quantum mechanics, for example. It's infinitely simpler than string theory. Currently, it is the only viable theory that can serve as a basis for a reformed physics, in my opinion. There are a few other theories, Harriman's theory and maybe a few other theories, but this is my view. It's gone beyond me. I mean, there's a huge community out there of people who are interested in it, and in fact, we even have a group that meets every Sundays to be developing further the equations to put vortical motion in the particle, in the nucleus, which that's the next step, to simulate vortical motion for spin. And anybody here who has computing abilities are welcome to join. Just need your email address to send you an invitation to the meeting. It reconnects us with our ancient roots and at the same time provides a platform that effectively explains things like free energy and anti-gravity. We find this encoded in ancient creation myths, in the Tarot, for example. So we are not the first to develop this, and this came from somewhere. It may not even be from Earth, but how they knew these things, where they would have needed computers to know some of this stuff, it's a big question, and it makes you wonder about the origin of this whole thing. So it is an ether theory, and it's very compatible with Tesla's thinking. More of a Tesla-type ether than the traditional 19th century ether here. So here, it'd take too long to get into all the details, but here we have it's an open system. Think of reactions. They're going on, transmuting from one state to another. So it's not just one type of ether. It's not a unitary ether. It's an alphabet soup of etherons or ether states. And they're going from one state to another. And here we show that two ether reaction pathways cross. And where they cross is where our physical universe would be located. All of our matter and energy would be made out of three ether states, G, X, and Y. The G would be for the gravitational field, for example, and X and Y for the electric field. And the reason why you need X and Y, why you need two, is because we have two polarities to electric charge, plus and minus. So in this case, it's a yin-yang type of relation between X and Y. Actually, Taoism, the yin-yang concept fits like a glove to these concepts. So X high, Y low, or Y high, X low. And then G, gravitational component, tags along with the X. So that's how you get bipolarity in the gravitational field. So you have input to our universe and output. And because we're located at this point in this flux, you think of it as an etheric flux, we have the sense of time. There's change happens. Now, if we were flowing with the change, with the transmutation, we'd be timeless in that case. So I call this the transmutational dimension, T. Now, there is no magnetic field in the sense of etherons that represent magnetic field. You just have electric fields that are moving. And this has been shown that all the equations of magnetism can be represented as moving electric fields. In fact, there have been some people who have suggested that maybe the magnetic field as an entity doesn't exist, that really the only thing is the electric field. So in current physics, we have the maxim, energy may neither be created or destroyed, only converted from one form to another. Now in subquantum kinetics, we change this. We say energy may be either created or destroyed, and can possibly be converted, of course, from one form to another. So is this blasphemy? I say no, it's reality. Why? Because the universe operates as an open system, and I'll proceed to show this. So here's the model G reaction system, which is at the heart of subquantum kinetics. Think of it as the genetic code that you start with to simulate the elephant. It's very much like the Brusselator reaction system that I started with, and all I did is put in the G in between A and X. Brusselator goes directly from A to X. I just put the G in. So it's a three-variable system. So think of that as the code of the universe. It's a place to start. You can modify the code. If you find it's not the best to fit the data, you can always tweak it. And we're still exploring just Model G. We have a lot of work to do on Model G, and so far it's done phenomenal things. I think it blows your mind what it's done, really. So here are the equations. They're called kinetic equations. Basically, I'm taking concepts from the field of chemical kinetics, and I'm bringing them into physics at the subquantum level. So you can call this ether kinetics. It's a set of 5 reactions, and you can write these as 3 partial differential equations with one for each of the 3 variables, G, X, and Y. And the terms on the right are the diffusion terms. So the first terms are the reaction terms, but you also you include diffusion. Now, when you stop to think, everything is either reaction and diffusion, like society. You produce commodities and you transport them. And because of these 2 basic processes, we have social economy. Look at your bodies. You produce molecules and you transport them to other parts of the body, and they're used and build things. So we deal with universal concepts here in subquantum kinetics that we see going on in other systems. That's the beauty of general system theory. It's like a song that's played in many different keys, and we're just bringing the song down to physics, so to speak. So now what we did, now I was doing this in my head. I didn't have the ability to do computer simulation. I was looking for a long time for people to do this. In fact, in one of my videos, you'll see me at the end saying that this is the next step. We need to find somebody to do the simulation of Model G. And then this fellow came to me out of the blue in 2010. He read Subquantum Kinetics and wanted to help. Magna cum laude in physics and mathematics from UCLA. And he managed to simulate this on his laptop, his Mac laptop. And here's a picture of the result of simulating. You start with the vacuum state where everything is uniform. The ether constant, you deal with ether-on concentrations here. And you wait, he inputs a little fluctuation, and it starts to emerge, and it grows. As long as the system is fertile in that place, well, the fluctuation makes it fertile. It's like a G-well fluctuation. And it turns out in this system, gravity wells create fertile conditions. It's like with a nuclear reactor. Nuclear reactor is like an open system, nonlinear system. It's like taking the fuel rods out of the reactor and starts to, reaction rate goes up. And subcritical, you put the fuel rods in and it dies down, it can eventually snuff out. So you see this grows and it develops into a little stationary wave pattern. And we call this a dissipative soliton. Prigogine was doing similar things with his simulations. In the group, he was just sort of the inspiration there. It was Lefebvre actually is the originator of the Brusselator, and his group there in the Brussels School were doing all the mathematical simulation work. And there, though, the wave pattern was all the way to the boundaries. It was unbounded, so it wasn't really physically realistic. Whereas Model G, now it's physically realistic. This would be an example of a neutron. So whereas Prigogine would call these dissipative structures, here we call them dissipative solitons. And the way that it maintains its structure in defiance of the second law, because you still have second law going on, you have diffusion. Diffusion is an example of second law process, because you have a high X on the left, low X on the right. This is like, imagine two boxes, two cells of this wave pattern. Let's say the core and the shell immediately outside the core. So you'll get X diffusing from the left to the right, but just as fast as it diffuses, it will react and be converted to Y by the reactions going on. So that way it ends up X is maintained low and Y is maintained high, and the same thing goes on the other side. So it's actually a homeostatic state, the non-equilibrium homeostatic state. It's stable. And here's an actual simulation. This is a simulation from Matt's simulating of Model G of a neutron coming into being. entire depth of the sea, potential would be the little wave on the surface. You zero out, you have a reference. So in the simulations, we deal with potentials. So everything in subquantum kinetics better to understand in terms of potentials, etheric potentials. So now, this is definitive proof that the universe operates as an open system. This, what we find here, because now this is a prediction of subquantum kinetics, this wave pattern, which you don't find anywhere else in physics, theory predicting this wave pattern around the nucleus of a proton or neutron. And in 2001, was published a paper by a fellow who was doing particle scattering experiments down in Virginia, and he found that, for example, this is, I show the neutron here, neutron, and you see this little low spot here, and actually has a high spot here. So it has a wave pattern. Here we plot in terms of, so we're plotting here charge density, the upper plot, like electric field. Imagine electric field of the particle. In the lower plot, we plot charge surface density, surface charge, which is a little different way of plotting it. It emphasizes more the stuff on the periphery. And that way you can see more clearly the wave pattern. So this validates what subquantum kinetics talks about. And I call this the Turing wave, this wave pattern. I've given it a name after Alan Turing, who was the first to propose about reaction-diffusion systems as applying to living systems back in the early 50s. So here, one of the characteristics in Model G is we have a nonlinear process. And how much time do we have? The clock's not moving. Okay. In subquantum kinetics, here's, for example, a wave equation, because you have waves in the reaction-diffusion systems, and they've written equations to represent waves in reaction-diffusion systems, and this is taking their equation. And you see this term here is the oscillatory part. And just like in physics, you have an oscillatory version for a wave equation. This is something new here. This is a imaginary part. And this can either cause exponential growth of the wave amplitude or exponential decay, or it can stay constant. Now, energy conservation is claiming this is constant, but that's a very special case in this open system physics. In Model G, the wave behavior is determined by the ambient gravitational potential related to the critical threshold of the gravity potential. So if you imagine a certain critical threshold, if you go below that threshold, this K factor will go negative, and it will become supercritical. Energy will increase over time. If you go above the critical threshold, the reaction goes subcritical, and it will decay out. And so the supercritical aspect leads to wave amplification, energy gain, and photon blue shifting, whereas the subcritical leads to photon red shifting. And subquantum kinetics predicts that the red shifting should occur in intergalactic space, which is very convenient. Actually, this is what brought me into cosmology, because I was working in physics at the time, and I was saying, geez, what is this, you know? It's not obeying the energy conservation law, and it's predicting that photons should redshift out in intergalactic space. And I was wondering, could the redshifter seen be actually this? I didn't know anything about tired light model, and that's when I started doing research, and I found, hey, they'd actually suggested this way back at Hubble's days, based on observation. And here I was coming from the theory side. And then I did my first cosmology test, and I was very stunned that it was actually supporting this model. So this was actually the first confirmation in my list of 14 confirmations. Then in the area of galaxies, we're in gravity wells, and so we're in supercritical regions. And here we get photon blue shifting, matter creation going on, which ties in with the title that we live in a supercritical energy amplifying galaxy. So it's in our galaxy, free energy is the rule, not the exception. Here again is the redshift test. This is a little more technical, showing that. And out in space, you get the opposite. So there's kind of a balancing going on where energy is lost in intergalactic space is being created, galactic space. Over time, you could say, more and more galaxies. And if you probably want to get into in Hindu philosophy, actually, it fits very much with that view of cosmology. They say that going trillions of years into the future, that the creation will be dissolved. So that could be like these reactions at the subquantum level could change and cause a dematerialization of everything, and we wake up and we find we are God all along. It's like Vishnu coming from his dream state. So to test the blue shifting prediction, basically if you have a star and it has a certain amount of energy, heat capacity, it should be producing energy from all its photons because they're blue shifting. Think of it like money in the bank that's producing interest. So that interest is energy that's giving off. And one day I had this epiphany looking at the sun outdoors when I was on Mount Tabor in Portland, and this clicked. And so I checked the data for stars and planets, because basically it was saying that whether it's a star or planet, this should be going on inside. It should be creating energy. And I had to come up with a name for this, so I called it genic energy. It's from the blue shifting of the photons, new form of energy. And we're talking about a very small change of energy. I mean, it's like you'd have to go 10 billion light years to see 10% change. Very small, but it all adds up when you talk about the billions and trillions of photons, quadrillions, in an object. And what I did is there was what is known as the mass-luminosity relationship for stars. They find that they follow a log-log relationship. Take the mass of the star, you plot it versus its luminosity. The more massive it is, the more luminous it is. And there's two relations. There's a lower main sequence and the upper main sequence. We're on the upper main sequence, the sun is. So why? Because fusion kicks in beyond a certain mass. So it's adding to this lower main sequence energy source, which subquantum kinetics predicts that it's genic energy. In fact, the genic energy prediction matches that slope. It's about 2.75 power. And what I did, I plotted the planets on the same diagram. Nobody had ever done that because it seemed like a ridiculous thing to do, because planets and stars are supposed to be entirely different. Planets, well, this was when they were just finding the results from the Voyager spacecraft and other spacecraft we were sending out, and they're finding, Jupiter is producing a large amount of energy in its interior. It's radiating almost as much as it gets from the sun, or in fact more. And the same for Saturn. Forget the statistics, well, I remember Saturn is producing 78% of its energy is internally generated. Check my book. I mean, I can't remember all the details, but it's all there. And in fact, they lined up on the same relation. And Neptune a little high there, but this basically shows that it supports this theory that it's genic energy is going on here. Because nuclear, you don't expect nuclear to be in planets, and you can't expect that heat of gravitation or whatever they say will cause the heat of the planets can't be applied to the stars because the star would have fizzled out its energy a long time ago. What's keeping it lit then? So I also plotted brown dwarfs. That data came out later. And as it came out, I would plot them, and sure enough, they were very close to the relation also. Now, getting back to the redshift, there are places where light in intergalactic space is blue shifted instead of red shifted. It's blue shifted when it goes through galaxy clusters, for example, and the closest one to us is the Virgo cluster. This picture of the Virgo cluster. And if you go out in looking out from the Earth as you go to the right here, this is a distance. We're going out. You see the redshift goes up as we go further away. But you get to the Virgo cluster. These are the galaxies of the Virgo cluster. And suddenly it takes a U-turn and it's becoming blue shifted. Instead of increasingly redshifted, that redshift decreases. And then once it gets out past the Virgo cluster, it continues going along its merry way again, same slope. This is called the Hubble flow here, by the way. This has not been explained by any astrophysicists, but it's explained by subquantum kinetics. Yeah. Now, another beauty is that this genic energy can explain where the energy comes from for supernova explosions. That's something that's very difficult to explain. Even Hoyle had a problem with that. You know, where does the energy come from? Especially in the hypernova. It's part of, if you read cosmology, you say, we don't understand what we're seeing here. This is a mystery and that's a mystery. Well, it's a mystery because they're operating in a closed system physics. It's like they're shackled with what they've been taught, and they're not able to come up with a good explanation. So here's a clip from my video, Parthenogenesis, Sacred Journey. This is the beautiful music of Ashana. The whole theme is that it's beautiful and sacred, and this is the new view that we have. It's a very positive view of everything. It's not black holes and things gobbling. It's a creation unfolding in a beautiful way. Okay. That's the Cassia simulation, NASA simulation of Cassiopeia A supernova explosion. The video has a lot of these NASA clips and NASA photos. It's a beautiful video, and it's got subtitles and beautiful music to listen to. And I think there might be a few left outside. So another problem is explaining galactic core explosions, and this has been a problem for cosmologists. Where does all the energy come from? It's much too much energy to explain by standard physics, because how do they get the energy? By matter falling into the core of the galaxy. Problem is that most of the images show matter coming out in huge amounts at very high velocity. And we see that these supermassive cores, they're at the centers of galaxies, most of them. They used to think they were quasars, the one on the right, image on the right. But when they got Hubble telescope up there, they realized that even like 3C273 is really the core of a galaxy. It's very bright, and it masks the light from the galaxy. Now, getting into some technologies that you can use to explain with this theory. Here's the Nasikas thruster, version 1. And it's a superconductor, like IBCO superconductor, that superconductors expel magnetic fields when they're cold, when they're cooled down, like with liquid nitrogen. This is a room temperature superconductor. And he puts a magnet in the throat of the nozzle. And it turns out the magnetic field is more concentrated inside here in the throat than it is outside, because the magnetic field kind of spreads out to zip around. So inside, there's more pressure against the IBCO, because the IBCO won't let it in, than coming the other way from the outside. And as a result, you have unbalanced forces, and these cancel out, the vertical, but you have a component that's pushing this way, and it will actually propel this axially. And here is a test that was done. He's Greek, by the way. You heard some Greek there. To the left. You see it swinging, very small amount, but it's always going to the one side. The reason it oscillates is because it overshoots its equilibrium. And yeah, it's now being evaluated. There's some interest in this for putting things on Moon, Mars. It's actually thousands of times better than the ion propulsion ideas they have. In terms of the thrust to weight ratio, thrust to power ratio. Well, it doesn't take any power. Yeah. So here we violate the first law of thermodynamics, because we're getting motion without any energy input, and Newton's third law, because we have a net thrust without throwing matter out the back. No rocket needed to push this. Yeah, so this is explained by subquantum kinetics, these violations, which holds that the generated magnetic field is seated in the surrounding ether and creates unbalanced forces on the nozzle. See, in standard physics, they think of the magnetic field being somehow tied to the physical things, like the magnet. But it's not. It's like the magnet is just creating an ether vortex. The magnetic field is really a vortex in the ether. And it's able to act on the thruster and push it. Also here, propulsion with no power input violates first law. And it's explained in subquantum kinetics, which holds that the universe functions as an open system. Magnetic flux is spin, particle spin, basically, which is ultimately animated by the subquantum etheric flux. And I have a slide to show you that at the end. Here is Townsend Brown's gravitators. This is another indication of how we can explain, in this case, electrogravitics. Subquantum kinetics, electric and gravity field are linked. So if it's a positive particle, gravity will make a gravity well. If it's a negative particle, like electron, it'll be a gravity hill. So electrons are actually anti-gravitic. And it's difficult to see in the laboratory because the gravity effect is very small compared to electric. But if you put huge amounts of charge on a capacitor, like Brown did, and you make the dielectric heavy, like barium titanate, which is very heavy, you get a force towards the positive pole. Now, the reason why neutral matter has a net gravitational mass or creates a gravity well is because the gravity well of the proton is deeper than the gravity hill of the electron by a very slight amount. And it's because the proton is a more massive particle. And so this is something we hope to show with the simulations, show these things to, rather than be just theory, but it makes sense at this point. So his gravitator is sort of like surfing on its self-created gravity wave. And this on the right is the example of this in rotary form. And general relativity can't explain this because it only predicts that masses can attract. And it predicts no connection between electric charge and gravity. And Tesla was saying he holds that space cannot be curved for for the simple reason it can have no properties. He says to say that in the presence of large bodies, space becomes curved is equivalent to stating that something can act upon nothing. I, for one, refuse to subscribe to such a view, so Tesla would be very happy with this. Here's a Brown's gravitator motor. So you could actually theoretically generate energy. Here's his vertical thrusters, which are, in this case, unbalanced forces play more of a role than electrogravitic forces. He's got the upper electrode larger than the lower, and the upper electrode, the field is further, more spread out, so the net force is weaker pushing down than pushing up, if you analyze this. 5 minutes? Okay. And if you compare it, the thrust to power ratio, you see that's way up there. This barium titanate thruster is 70,000 compared to the jet engine, which is 15. Space shuttle is only 0.2. So in terms of efficiency, jet engine around 30%. His thruster version 2 is 140%, 140,000%. He also had this electrokinetic disks. I am Secrets of Anti-Gravity Propulsion. I propose this is the power for the B2. It's what thrusts the B2 forward. And it came out of some disclosures from Black Project scientists that said the B2 actually charges its leading edge of its wing. And here's an explanation of how that happens. The ions in the front are very spread out, whereas the ones behind it, coming out its exhaust ducts, are very concentrated. So the force is very strong pushing it forward and very weak pushing it back. And this is an example of the flame jet generators the B2 uses generates its thrust. And quantum mechanics is a flawed theory. This is Schrodinger's view, where it's like a particle with its wave packet tagging along, and depends on which observer views it as to what is the wavelength. The problem is it doesn't fit in the hydrogen atom. The little circle in the middle is the Bohr orbit of the hydrogen atom. That big circle represents the size of the wave packet. And that's why he had to go to a non-classical view, and that's where quantum mechanics went way off in left field, mathematical and without conceptual models. Well, the nice thing about subquantum kinetics is you have this as Compton wavelength. That Turing wave pattern is at Compton wavelength size. And that's where the wave is. It's embedded in the particle field. And here it shows you the Compton wavelength. And so it's able to, if you do with the subquantum kinetics approach, explains all of de Broglie's particle diffraction experiments, where they got the wave aspect of matter, explains orbital quantization of the hydrogen atom, and it predicts the existence of energy levels below the ground state, because now it's very small. And if you go to lower speeds, you should be able to have other orbits where it still fits, because here you see that little black dot is the size of the Turing wave, the Compton wavelength, and it's 68 times smaller than the circumference of the Bohr orbit. So there's no problem here. So you can just view this classically. So if these are energy levels, there the n equals 1 would be the ground state. The idea is you could theoretically get this to jump down. That's what Randall Mills is saying, and that's where he believes he's getting his power. He calls this a hydrino state, where the electron jumps down, except he does it with like 3 volumes. It's like a 1,000-page book. In subquantum kinetics, we do it in 3 pages. Here's his current energy cell. It's a 1 megawatt sun cell, he calls it. And get into, we're getting very close to the end. This is the etheric fluxes, which would be the origin of spin. And it has to do with the flow of ether, the ether flux coming from the core to the next surrounding shell. not only it's going radially, but if this becomes unstable, starts rotating, you would get spin formed. This is actually from the theosophists, Annie Besant and Charles Leadbeater, who actually predicted not only spin before it was discovered, but also Lamar precession. And they're not recognized, unfortunately. So with spin, you can get nuclear binding. You don't need nuclear forces. These bind. And you can also get Cooper pair formation for superconductors, can explain Cooper pair binding in superconductors. And also, Theo mentioned in his lecture charge clusters. So you just have larger agglomerations of these in a plasma state, maybe aligned by a magnetic field, and you get billions of these. And then when suddenly the magnetic field collapses or something, it releases the energy, you can get a huge explosion. That's probably what happens with lightning strikes. And this is pretty much almost the last slide, yeah. So at the bottom we have Tesla's wheelwork of nature, the subquantum etheric flux, which is driven by etheric force, the prime mover. So you go above the green line, and now we're getting to the quantum level. So that is creating the subatomic particle wave pattern, the Turing wave pattern, as a result of that etheric flux. From that, it generates the etheric vortex. That's where you get spin, magnetic field, and with the right engineering, you can get free energy. So this, here, in a way, we're connecting to Tesla's wheelwork of nature. Then zero-point energy is another avenue which people have suggested. But in subquantum kinetics, it's not like the physics view of zero point. There's subquantum fluctuations. You have to wait a long time to get one big enough to even create a subatomic particle. So this is a big question mark, whether you could actually engineer that. But it is important in cosmology, because that's how matter is created in this physics. Thank you.